Tervetuloa, willkommen, welcome everybody to our virtual wind energy conference. My name is Christina Zenke, and for the last 6 months I was leading the project that this conference is a part of. Therefore, I'm very excited to be welcoming you today and to be your host during the whole conference. And I hope you all found a comfortable seat by now and a nice cup of coffee or tea of your choice at your side so we can get started. But before I tell you a little bit more about our program today and about the whole project, our acting managing director, Dr. Jan Feller, would like to say some welcoming words.
Good morning, dear participants from Germany and Finland. Great to have you with us. My name is Jan Feller. I'm acting managing director of the German-Finnish Chamber of Commerce. Germany and Finland are very active trade partners for many years already. Finland is actually Germany's most important trade partner, both in imports, sorry, the other way around. Germany is Finland's most important trade partner, both in imports and in exports. And that trade covers physical goods, covers services, and in the recent years, digital expertise, a lot of that as well. While windcraft expansion has been a bit stalling in Germany, Germany has many world-leading companies with high expertise in the various parts of the industry. And some of these are visiting us here in Finland today and will meet Finnish windcraft, wind energy players later this week as well. So without further ado, thank you very much for being part of this virtual meeting, virtual event here. I'm wishing you lots of interesting new ideas, new contacts, and please be active in the chat today as well. Have fun.
Thank you very much, Jan, for the opening words. And so just for the background, some of you might already be familiar with our energy-themed conferences, and I know some of you really can't stay away from our energy-themed conferences, and we're very happy about that. Please also come back next year. But today, for the first point, today's conference is different in two ways. For the first, it's the program is a bit shorter today, and we will have one speaker from Germany and two speakers from Finland, as well as several short pitches of German companies. But what's the biggest news or new thing this year is that we are all meeting here online and not in person. So we gladly accepted that challenge that COVID-19 was giving us, but please be indulged with us if there might be some technical hiccups during the event. Because in the end, we are only digitalized human beings and not artificial intelligence quite yet. But talking about technical hiccups, let's say quickly hi to our directors in the background, my colleagues Friedrich and Antti. Hey there.
Hi. Yes, so maybe I hope you will not hear so much from us. So.
Yeah, we all hope that. But it's good to know that you're there anyway. Okay, but we have a rather tight schedule today, so let me just introduce you or explain you some of the features using the webinar tool Webinar Jam today. So first of all, you might know that already from other webinars. In order to have the best possible experience, please close unnecessary windows and browser windows and programs in the background. And what is most important for you as a participant is that you have the chance to communicate with us via the chat on the right side of your screen. If you can't see the chat yet, just click the 3 white dots on the red background and it shall magically appear there on your screen. So what's important that during any time of the webinar, you just enter your comments, your questions, whatever comes to your mind. If you need help with some technical stuff, just enter it in the chat, and depending on how many questions we will get during the present or after the presentations, We might not be able to answer all of the questions right away during the webinar, but we will collect all the questions and forward them to our experts, so you will get an answer later on. So actually, to make it easier for us, please mention in the comment to which presentation your question refers. And then there's one more thing in the beginning to get you familiar with, and that is our poll function. So in order to keep you awake and happy during the whole event, we will have a couple of polls from time to time, because everyone likes to push buttons, I was told. So let's have a quick test. Let's start our test poll. Yeah, so the first question of our test poll is, what was the share of wind power in German electricity production in 2019? Was it A, 17.8, B, 21.9, or C, 24.4? I will give you some time still to answer. Okay, so let's wrap it up. Okay, there's still some movement. I'll just give a couple more seconds. Okay, so let's stop it here. It's just a test to get you familiar with the tool. So the right answer is C, 24.4. So in 2019, wind power overtook lignite or brown coal for the first time and actually became Germany's most important energy source. That was mainly due to a very windy year, and the numbers look pretty good, I'd say. But in the end, the German wind energy sector is nevertheless struggling quite a lot lately. The market seems to be rather closed off, and right now there's not much room for expansion. And that is mostly due to the lower acceptance of wind power expansion in the population in Germany. So just as a background information, why it was actually such a high number last year. Okay, but let's get started. So if something, just to say it again, if something comes up or you experience some complications during the webinar with the audio or something that is not working, just let us know in the chat and we will do our best to help you out. But let's start with our first presentation for today. As I mentioned earlier, this virtual conference is part of a bigger project that is financed by the German Federal Ministry for Economic Affairs and Energy. And the so-called German Energy Solutions Initiative aims to support German SMEs that offer climate-friendly energy solutions to open up foreign markets for them. And during the whole event, and actually already for a couple of years now, we've been working closely with the Berlin-based consultants of Energiewächter GmbH. Hi. And Ferdinand Elsässer of Energiewächter will now give us a short introduction of the initiative.
Yes. Yeah, thank you very much, Christina. Hello, everybody from Berlin here. It's also my first time in a really virtual conference, so I'm also looking forward that everything is working fine. So to start now, I just want to give you a very brief overview of the German energy transition. And right now I'm seeing that I'm not Dr. Lorenz Müller, and this is not my presentation. So it would be great if you could change to mine. Thanks. So maybe I can just start and say a little bit why we started the German energy transition. I think the reasons are pretty obvious, but I just give you some ideas. Of course, the nuclear phase out in Germany is a really big thing going on, which has started already in the 80s, like the idea of the nuclear phase out with Chernobyl, and in recent years, of course, with the Fukushima catastrophe, this has led the Germans to phase out nuclear energy production in general. The second reason was to reduce the high dependency of fossil imports, which mainly come from Russia. And additionally, Germany wanted to set an example that a sustainable energy system can be, well, sustainable, but on the other hand, also economically successful. Yeah, that's why we set up the German energy concept for the phase out of the nuclear energy and for the introduction of renewable energies in Germany until 2050. And well, here we can have a look at the general energy concepts and the goals. I mean, of course, one of the main goals is to reduce the greenhouse gas emissions by 80 to 95% in 2050. The share of renewable energies has to grow, of course, in the gross energy consumption as well in the gross electricity consumption in general. And on the right side, you can see that energy is always best when you can save it. This is the cheapest energy. That's why Germany has also set a path to improve its own energy efficiency in industry, in transports, or in the housing sector. Actually, it should double from the baseline of 1990 until 2050. Yes. Well, as Christina has already said, last year was a pretty good year for wind energy. Here we see some numbers from 2017, where the share of renewable energies was 33% in the total electricity generation. I also have the numbers from last year. The renewable energies already reached 46% in the total share of renewable energies. And as Christina has said, so renewables have already surpassed lignite, hard coal, or even nuclear energy as well. Excuse me. So if we take a look here on the right, of course, you can see the shares of the different renewable energies. And as you can see, wind power, wind energy is already the strongest source of renewable energies in Germany, with around 13.6% being installed onshore and another 2.7% of the whole electricity generation being installed in the offshore sector. And well, as we heard in recent years, the growth in the onshore sector really has come to a halt because, well, most of the best sites are already in use. And in Germany, we, of course, also do have our NIMBY discussion. So nobody wants to have new wind power plants close to its home. We even have the problem that the transmission lines are becoming a problem for Germany. Yeah. And well, today the growth of the German wind energy production is now located in the offshore sector in general. In contrast to onshore sites, the development of projects needs much higher investment costs, and that's why the ownership structure in this offshore market is also different from the one in the onshore market, which means that okay, I really have to hurry a little bit up. So here you can just see like the geographical spread of renewable energies in Germany. So wind is located in the north, where it's flat and windy, and also in our low mountain ranges in the middle of Germany, whereas photovoltaics is mostly located in the south of Germany. Well, and here you can just see the general idea that most of the wind energy is produced in the north of Germany, and the consumer centers, they are located in the south or in the west, let's say Stuttgart and North Rhine-Westphalia with their big industries. And that's where we have the bottleneck to bring new transmission lines to the south, where we also have just right now this political discussion going on in Germany. Yeah, and well, this is just for the last slide of this introduction. As you can see, we do have a very high share of renewable energies in Germany as well, or already, but our security of electricity supply is still one of the best in the world. So I think we can be happy with this and look forward to install even more wind energy in Germany. Yeah, and so I think now I'm coming to a halt, and thank you very much for your attention.
Mikro an, Christina, bitte.
There's always so many buttons to push. So thank you very much, Ferdinand, for the short introduction of the initiative. And let's actually just go on with the first keynote speaker of today, from our one speaker from Germany. Dr. Lorenz Müller will be talking about the grid integration of wind energy in Germany. And Dr. Lorenz Müller did his doctorate in engineering at the chair of electrical energy supply, and he began his professional career at the end of 2003 at what was then Vattenfall Europe Transmission GmbH in Berlin, and is now 50 Hertz Transmission or 50 Hertz Transmission GmbH. And since then, Dr. Müller has held various management positions. Since 2016, he is the head of regulatory management, where he represents the company as the communications representative face-to-face with the Federal Network Agency, and is responsible for the regulatory treatment of revenues, costs, and processes. So, stage is yours, Dr. Müller.
Okay, thank you very much. So, good morning, everybody. Also from my side, I would like to tell a bit about the grid integration of renewable energies, and especially wind energy in Germany. Ferdinand and Elsässer already showed some slides which are similar to mine, so I can be brief on that. Yeah, in the next 20 to 25 minutes, I will give you a short overview of what we're doing in Germany and how this looks like. Okay, so as already said, I'm a representative of 50 Hertz. 50 Hertz is one of the 4 German transmission system operators. So we are located in the eastern part of Germany and Hamburg. So basically the so-called new federal states of Germany. You see the blue color here on the left, and we're located in the heart of the interconnected European continental transmission system. Yeah, I can be brief on that because that was already shown. You see here the policy targets for renewable energies in Europe and in Germany, and you see with the European Green Deal of last year, end of last year, Europe is even as ambitious or even more ambitious now than Germany. And I'm pretty sure that Germany will follow here as regards 2050, which of course is still a bit ahead. So more important, I guess, is 2030. There we are both as ambitious with 55% CO2 reduction. What was already mentioned by Ferdinand Elsässer is that we decided in Germany to phase out nuclear energy and coal, so lignite and hard coal. Of course, these production capacities have to be replaced by renewable energies, and I guess a bit of gas as well. But of course, the idea, the target is that renewable energies will take over here. That was already shown. You see the developments over the last years, starting in 2000s with a few red dots. Red dots are wind energy. Then in 2006, even more, mainly in the north of Germany. 2018, a bit or much more colored. You see here the red dots, wind, the yellow dots are photovoltaic. And you see that mainly in the north, wind is located, and in the south, photovoltaics, of course, due to geographical reasons. But wind energy is still far ahead. Of course, this means because the load is located mainly in the western and the southern part of Germany, a bit or a huge necessity of transport capacity, transfer capacity between the north and the south. I will come to that later. Here you see the growth of renewable energy sources in Germany, and you see that it's quite a very stable growth path, and it is expected to nearly double again over the next 11 years, so or 10 years, let's say. So until 2030, it will double again. And you see here in blue onshore wind. With onshore wind, we have the issues explained by Ferdinand Elsässer that the space for new onshore wind installations is limited because there are minimum distance requirements to households, to cities, and simply the space is not in my backyard discussion here. So offshore wind energy will play a much bigger role than nowadays. Even today, it's becoming to play an important role, but this is expected to grow even stronger over the next years. And the yellow colored photovoltaic installations here, of course, will remain as important as they already are today. In our control area, it's the same path, just because not all years are displayed here, but you see the growth path. And I have to say that we were always too cautious with our forecasts in the past. So real life overtook our forecasts. So I'm pretty sure that this development will continue as shown here, or will even be stronger. And you see here that in our control area, wind is even more dominant than in the rest of Germany because of that geographical distribution I showed you before. As I said, offshore wind is becoming more important due to the distance requirements and the not in my backyard discussions for onshore wind. And you see here the exclusive economic zone of Germany where offshore installations can be built. You see on the left part of the picture of the slide, the North Sea, which of course is bigger than the Baltic Sea. The exclusive economic zone here is much bigger, so there is much more space for offshore installations. But also in our control area here, which is the Baltic Sea, on the right of the slide, there are already several offshore wind farms, and further wind farms are planned and are already under construction. So you see the green wind farms which are already in operation. For instance, the cluster Westlich Adlergrund on the right of the slide with wind farms Wikinger and Arkona. That's the biggest wind farm in our control area. And by the way, the export cables were partly produced in Finland because there is a big Prysmian factory there in Pikkala where the export cable was produced. So this is now in operation and is a big offshore wind installation. As regards the grid connection, the technical concept for offshore wind, we have mainly two concepts in Germany. One is the AC concept, which we mainly use in the Baltic Sea because the distances are shorter. And then there is the DC concept, so direct current and alternating current concept. The DC concept is mainly used in North Sea because of the longer distances, and that's the main difference between both. So you can use AC concepts or AC grid connections for distances of, let's say, up to 100 kilometers. And the main advantage is that you get rid of the huge converter platform offshore, and therefore, or thereby you reduce the costs significantly. So the costs for an AC grid connections are basically lower than for DC connections. But you need to go for DC concepts when the distance becomes too big. Here you see the schematic representation of a grid connection. You see on the right the wind turbines and the platform. In the German waters, and it's the same in the Baltic Sea normally, so the same for Finland as well. The water is relatively shallow, so usually you find places where you can work with let's say normal foundations. You don't need floating foundations, which is a concept which becomes more and more popular, or let's say necessary in other countries like Japan, for instance, where the water is too deep for normal foundations. Of course, you get other issues with the floating foundations, what to do with the cables, how to anchor the whole thing, and so on and so forth. But as I said, in the Baltic Sea, the water is normally relatively shallow, so you can go for normal foundations. And then, of course, you have the export cable marked in orange here on the picture. And you see different things we face here when burying a cable. So, of course, you have a very different soil conditions in the Baltic Sea due to, let's say, the way the Baltic Sea was formed by the Ice Age. So you have peat, you have sand, you have mud, you have rocks, and all these things in only one cable route, and you have to cope with that when burying the cable. Then you have unexploded ammunition, you need to clear the cable route from old ammunition. You have crossings with pipelines, with other cables. You have archaeological items like wrecks you need to consider. And all these things make, of course, a laying of a cable, of a grid connection challenging, but we, of course, have developed tools and ways to cope with these things. The offshore wind has different benefits, and that's not only the distance, the low distance, the fact that you don't have to cope with a NIMBY, or you have less problems, let's say, with the not in my backyard discussions with the distances to households, but you also have higher availability of the grid connection than expected. You have much higher usage hour. We have more than 4,000 usage hours per year in offshore wind, whereas in onshore wind it's let's say half of it. Of course, that means that the predictability is better for offshore wind. The fourth point is what I already mentioned. This is the not in my backyard discussion for onshore wind. So you have less public concerns, less people are directly affected, of course. It's, let's say, easier to get the permits for a grid connection and an offshore wind farm, even though it's still challenging, of course. The last point is that, of course, especially in the Baltic Sea, the Baltic Sea is not that big. So the distances between the countries are not that big. So you can use offshore installations, offshore wind farms and grid connections to interconnect countries. So if you have a connection, let's say, to Germany, and then the distance, for instance, to Denmark or to Sweden is not that big, you can have a second or an additional connection to these countries and thereby create an interconnector. And that's what we did in the Kriegers Flak area, for instance, for the combined grid solution. So this is a an area where wind farms of Germany and Denmark are located. And then we had the grid connections to the German grids, and we had the grid connections to the Danish grid. And there it was very obvious to just connect the grid connections offshore and thereby create an interconnector together with the wind farm connection. And that's, of course, a clever solution, because if the wind is not blowing that strong, you can use the capacity of the cables to connect the markets here. So this is a pilot project, also subsidized by the European Commission because of that. As was already mentioned, the geographical location of wind energy especially, and renewable energies in general in Germany is, as you see here on the slides, so mainly in the north of Germany, there is the generation. You see here always the columns here. The dark one is the generation, and the orange one is the load. And you see that the generation in the north exceeds the loads significantly, because basically not many people are living there. It's a rural area, which is of course very apt for renewable generation, for wind generation especially. But that means that you need to transfer the generated electricity to the north, where the industrial centers are located, to the south, sorry, and to the western part, where the industrial centers are located. And that means you've seen a similar slide in the presentation by Ferdinand Elsässer. That means that there is a big transfer necessity from the north to the south. So an increased need for transmission of about 25 gigawatts, which is significant. So we need actually to build that grid. And building a grid is even more challenging because of public acceptance than building new generation capacities. So this is a big challenge for the next years. We're already in that process, of course, but building new lines from the north to the south is a big challenge. But it is necessary to make the energy transition happen, because without the line, nothing will actually happen. Then we cannot feed or generate as much as needed for replacing fossil fuels. And you see here what happens if the grid is not strong enough. We needed to do significant, and we still need to do significant redispatch measures. So redispatch means that on both sides of a congested line, you adjust generation. On the, let's say, surplus side of the congested line, you decrease the generation. And on the deficit side, you have to increase generation, or decrease load would be another measure, but usually you try to increase generation here, which of course causes costs and is not what is intended. And you see what happens here in the last years, from 2013 to 15, volumes and cost for redispatch increased significantly. And then you see the effect of a new line, which shows that building new lines is a very necessary and reasonable measure. That was the commissioning of the so-called Southwest interconnector, which connected our control area even stronger to the control area of TenneT, to the south of Germany. And you see the effect on especially the cost here. You see 350 million in 2015, which then nearly halved to 180 in 2016. So this effect is of course significant, and you see here once again on that slide that the costs we saved by means of this interconnector is already above 750 million euros, so much higher than the building cost of the interconnector, and that shows that such a measure, such a reinforcement of the grid is a reasonable measure and a necessary measure. What is necessary to make the energy transition happen and successful? Basically 3 elements. So one is, of course, what I already mentioned, an efficient promotion of renewable energy plus a grid expansion. So you need a strong grid, and of course you also need further installations of renewable energies. So you need to get the acceptance in the public for these measures. As I said, offshore wind is easier at this regard, or in this regard, because less people are affected. Grid expansion is always a challenging issue. The second element is clearer roles and responsibility. What is actually the role renewable energies have to play if they are intended to replace fossil fuels? Of course, they need to take over some of the responsibilities the fossil power plants nowadays still take. So let's talk about, for instance, reserve power and voltage control, so ancillary services. They need to take over these roles. And of course, you need, as a third element, a market design which is appropriate to include and integrate renewable energies. Control reserve markets, I already mentioned, congestion management markets, security of supply, all these things need to be taken into consideration. So these are the 3 elements we need to develop, and we are on the way to develop, but there's still a lot to do, of course. As regards the normal grid operation, so everyday operation, of course, fluctuating in-feed of wind energy and solar energy is a challenge. You see here one day, this was one day in 2018, where you see the maximum feed in 15,600 megawatts. And you see that, of course, it's not always easy to cope with that fluctuating energy, especially if there are deviations from the forecast. So you need, of course, flexible tools to cope with that. But it is possible to cope with that, as you see here. This is also already mentioned by Ferdinand Elsässer in his presentation, the security of supply and the so-called SAIDI, so the number of not, how do you call that, system, it's called system average interruption duration. Yeah, that's the abbreviation. And you see that this index is very good for Germany. So you see, despite of the high share of renewable energy, 60% in that year here, or that moment, you see the very low number of interruptions in Germany, especially also compared with other countries here you see on the right of the slide. To summarize everything here, so to reach Europe's and Germany's policy targets, you've seen on the first slide here, to reduce CO2 emissions, to integrate renewable energies, we need that transition from the fossil fuel dominated energy system to a renewable energy system based on wind energy and photovoltaics, because we don't in Germany have that much possibility to use water, for instance, like other countries have. Water has already reached the limit, so it's only possible by fluctuating renewable energies like wind and photovoltaic. We are already well advanced in this regard. We have almost already a very high share of onshore wind and photovoltaics, and offshore wind is steadily growing and increasing, and is becoming more and more important and relevant due to that NIMBY concerns and of course also predictability issues or aspects. It is possible to maintain the high security of the system and the quality of supply with renewable energy, with fluctuating renewable energies, if you have the right tools and of course if you have a strong grid. So huge investments into the grid are required. New lines are required to cope with that changing infrastructure here, changing in-feed structure, and the resulting load flows. And an issue is that the construction of a line is slower than the construction of generation capacities. So in order to cope with that difference in timing, also other tools, flexible tools for operation are becoming crucial, and we are also working on that for the operation of the grid. So thank you very much.
Okay, thank you. I would have actually needed to stop here also here. Thank you very much for the very brief overview over the onshore and offshore sector. I know you had a hard task here covering both parts for Germany during the short time we have today. But let's take still a couple of minutes for one question. And the question is, how do you see the potential of repowering existing sites with larger and modern turbines? Could the turbines built in the late 1990s and early 2000s be replaced with more modern ones?
Of course, there is some potential for repowering. Of course, you only get, let's say, a limited amount of energy out of a space. But of course, if you, I mean, with that, it's not possible if you have a kilowatt installation here and you have maybe 20 kilowatts or 20 turbines in the kilowatts size here. It's not possible to replace them by 20 turbines in a megawatts size. That's not possible. But of course, there is potential for repowering. And this is something we actually are thinking of, because we are considering at the moment, because many of the old, of the first installations in wind power have come to the end of their life cycle. And of course, as I already mentioned, the space is limited. So you actually need to use the space for new turbines here, do a repowering. If the foundation of the wind farm is appropriate for a bigger turbine, you can do that. Otherwise, you have to, let's say, deconstruct the old one, build a new one, but of course use the space here, and if possible, use also the grid installation here.
Okay, thank you very much. And I think you're still here for a while, so maybe there's also a chance. There's a couple more questions in the chat. Maybe you got some time to still answer a couple of those.
Thank you.
Thank you so much. Okay, but we are a couple minutes late, but that doesn't matter so much. So let's go on to the next big part, let's say, of the webinar, our German company presentations. So as I mentioned earlier, the conference is part of a bigger project financed by the German ministry, and another part of the project are the individual B2B meetings that we are arranging for the German companies that are also presenting here today. So those in total 8 German companies, they dedicated this whole week to Finland. So in case they spark your interest now, please get in touch with us, and we can still arrange spontaneously individual virtual one-on-one meeting still for this week. So let's start with the first 4 companies, and later on we will have another 4. So the first company presenting will be Geonet Umwelt Consulting GmbH, represented by Judith Marquardt-Bach.
Hyvää huomenta, good morning to Finland. My name is Judith Marquardt-Bach, and it's a pleasure for me to talk today about our company Geonet, your wind expert in Finland. Do you see my... okay, you can see now the presentation. So, who is Geonet? Geonet is based in Hanover and has been conducting wind and energy yield assessments and wind measurement campaigns worldwide since 1996. Our team consists of an interdisciplinary group of 40 experts coming from various scientific backgrounds, like geographers, meteorologists, and engineers. So what do we offer? Our services are wind potential study and wind atlases for whole countries or regions. We do wind measuring concepts and conducting wind measurement campaigns with mast and lidar. We offer bankable measuring reports and energy yield assessments, as well as microsightings we do, turbulence, noise, and shadow expertises we offer as well, and we do technical due diligence. So here you can see our worldwide experiences where we did already measurements, wind potential studies, and IEP reports. And the table below shows the realized wind farms. And as you can see here, we already realized 5 projects in Finland, 1 already built and running with 21.5 megawatt near Oulu, and 4 more projects are in the planning process, which we supervise. So Geonet works with its own wind field model since more than 20 years, which is like a CFD model. Finnland means a flow over irregular terrain with natural and anthropogenic heat sources, and is a meteorological 3-dimensional static model for the simulation of wind field, and it's applicable in all terrain types, including very complex topography. So, and it has explicit modules, for example, flow over forests, which is very important in Finland, and employees who are refining the model all the time to meet the high requirements for in the field of wind energy. So here it shows the model input data of Finnland 3D. We have the meteorologic from global upper level wind data from reanalysis and mesoscale model output and in situ measurements. We use as well data from ATCAS or topographical maps or satellite images, and the orography data from elevation models derived from topographical maps or remote sensing data. So altogether, Finnland assesses for each grid specific wind statistic, and this for up to 36 wind direction sectors. So as our model is as good as others, what are the advantages of Finnland? It does realistic modeling of the wind flow in complex terrain and modeling of turbulence and flow inclination. It considers the representative atmospheric stability and Coriolis force. Also, regional climatic phenomena can be simulated and integrated into the wind analysis. And detailed modeling of forests and woodland. So if you go there. So as I mentioned, one of our main services are wind measurement campaign, where we do the conception organization and implementation. We have the newest accreditation now from 2018, and we do this IC compliant model-based selection location. The mass construction and maintenance will be done by local partners from Finland. Technical acceptance of the measurement setup, control, and remote monitoring of wind measurement data. So we evaluate the data, measured data every day, and monthly reports. And after 12 months, we offer bankable reports about the wind measurement campaign. Here you can see a LiDAR measurement, which we organized near Oulu up, and due to higher heart rate, it's becoming more and more interesting to measure with LiDAR, but also more challenging. So because the data evaluation requires advanced knowledge, like the characteristic of measurement values is different to compare to the copper millimeters, and measurement error and uncertainties are quite sensitive on terrain and measurement. So GeoNet offers the conception of the whole measurement campaign. We select the measurement side with error, so we offer error maps. We do the installation and acceptance of the LiDAR on site. We can also offer the verification of LiDAR after the measurement. And we can also provide to Finland LiDAR devices with power supply. So coming to the end, GeoNet has brought international experience, gained from more than 4,000 projects now in Europe, also Finland, Latin America, Africa, and CIS states, where we have offices. We offer also in Finland very competitive with high cost-benefit factor independent services for your wind energy project in Finland, and we provide internationally recognized and bankable wind measurements and energy reports in highest quality. So, kiitos huomiosta for your attention, and I hope to hear from you soon.
Thank you very much, and thank you also for trying to speak that complicated language. Your effort is very much appreciated. There is no, as I see, no questions in the chat, but I would have a question for you then. So just to sum it up again, or bring it up a bit more, where do you see your strengths compared to competitors, especially for Finland?
Sorry, I couldn't understand the question.
Where do you see your strength compared to competitors, especially for Finland, for the Finnish market?
Once we have a lot of experiences with LiDAR now. We did more than 50 LiDAR measurements worldwide, and we offer error maps, so we place the LiDAR in the exact place, and we do with Fitness 3D the LiDAR correction we invented, because sometimes measures 2% less than measurement must. So it's very interesting.
Okay, thank you very much. Actually, there was just another question coming in, but as you will be still here, maybe you could give Jonas then a written answer on that question still.
Okay.
Thank you so much.
Bye.
Bye. Okay, let's move on in the program and right away to our next German company called Anemos GmbH, represented by Lasse Blanke.
Hello, thanks for the introduction. Just waiting for my slides. Yeah, let's start. I will give you a broad overview of the company and our services in the next short 5 minutes. And let's see to our company profile. We are acting in the wind energy since 30 years. At the moment we have 16 employees, mostly meteorologists or geographers. We are a worldwide acting company for working at more than 5,000 wind energy projects in more than 70 countries. We have several certifications and memberships. The most important in Germany is accreditation, but as well several international memberships. Our customers are mainly wind farm developers, but as well in the last time it's more shifting to private and institutional investors interested in buying existing wind farms. Further customers are financing institutions and public authorities. There are few of them are depicted, but I will go further to our services. I marked in bold letters the services we provided already for projects in Finland. The main services are starting for a site assessment study with wind measurements and wind data analysis, with met masts, LiDAR or solar devices. The main tasks for bankable wind studies are site assessment and site suitability. We are performing this for complex terrain with a CFD model, with Meteodyn, or in simple terrain with a standard program WASP. We are performing environmental studies like noise, shadow, turbulence. As I said, one main part in the last years is the due diligence process in the pre-construction of a wind farm. This is a review of external site assessment studies. But more focusing in the last year is the analysis of operational wind farm. Then the operational SCADA data is analyzed and long-term corrected to get a production for the future operational periods. This is mostly after 1 or 2 years of operational of the operation of the wind farm. This is a common process. In this process, it's as well possible to do a detailed power performance analysis of the SCADA data to maybe get an optimization of the wind farm to get a few more % out of the wind. One of our main focus is the mesoscale modeling with WRF and the generation of wind atlas. We are mostly focused on European countries. We have a detailed wind atlas for Germany and France, but as well for Scandinavia. We have a wind atlas with 10 kilometers resolution and 1 minute. 10 minutes data. With the wind atlas, we can do icing maps or extreme wind calculation or wind and energy yield for operational wind farms. You can get the data online with an information system, data access, and the wind atlas data is as well very useful for electricity market analysis, like PPA analysis and revenue reports. We are doing as well portfolio analysis for huge portfolios consisting of wind farms and PV. And our references in Finland, we were part of 15 wind projects in the last 5 years. Just a short overview of our customers in these projects. And I can give you a short slide with an overview of our wind atlas for Scandinavia. On the left-hand side, you can see just a wind map based of the Scandinavian wind atlas. In the middle, you can see the icing map with the losses due to ice. And on the right-hand side, there's a wind index map for the year 2019, where you can see that in the southern part of Finland, it was a very good wind year, but in the northern part, the wind year was not that good. But most of the wind farms are installed in the southern or middle part. In total, it was a good wind year for Finland. Okay, that was it.
Okay, thank you very much for your presentation. And also, as there's no question in the chat yet, I will step in again. And so you mentioned the temporal resolution of 10 minutes of your wind atlas in Scandinavia. So why is this unique high temporal resolution so important?
Yeah, because in different to the normal reanalysis data, like mesoscale data, like ERA5 with a temporal resolution of 1 hour, our atlas has a temporal resolution of 10 minutes, which is very important if you're looking at the operational data. The SCADA data has as well a temporal resolution of 10 minutes, and the wind turbines are acting very cautious of the changing wind. So you need this temporal resolution to analyze this data. And as well as already said in the previous presentations, electricity price is very volatile and has fluctuations. So if you have a wind data with a resolution of 10 minutes, you can analyze and combine this data perfect to analyze this.
Okay, thank you very much. And yeah, just as a reminder, as we have already heard now, 2 companies, you have the chance to still meet them virtually this week. So if you're interested, don't forget to get in touch with us. But let's go on then to, as we're a bit behind in the schedule, right away next will be GE-Net GmbH, represented by Dr. Carsten Rohpeter. Wir hören Sie noch nicht, Herr Rohpeter.
It's done?
Yeah, yes.
Yes, I'd like to welcome everybody. I am very proud to be part of the finish of this presentation, and I'd like to tell you something about our company. I'm just waiting to see these slides.
Herr Rohpeter, machen Sie bitte noch mal das Whiteboard aus. Dann können wir die Slides sehen. Das Whiteboard erst bitte, nachdem wir die Slides.
Okay. Yeah.
But I forgot English, so yeah, English, please.
Okay. some technical issues. So I'd like to welcome you to my presentation. Let's give a short overview. The company is called GE-Net, which was basically the name for a company for sustainable energy technologies. We are located in Clausthal-Sellerfeld, which is more or less in the center of Germany. And at the moment, we have 25 employees. So the company itself was already established in 2001. So we are nearly 20 years on the market. And more or less right from the beginning, we are focused on the wind energy sector. And also right from the beginning, the supply and installation and the performing wind measurements was one of our main tasks. And until today, we have supplied around 400 metmasts worldwide. So we are very specialized to this very small part within the wind energy. So here you can see where our main markets are. So we have supplied MetMast and have done installations in more than 60 countries worldwide. Whereas at the moment, our main markets are basically, of course, here in Europe, and also main markets are in the Near and Middle East. And also right now we will have some projects in the US. So in other countries like South Africa, that we have been some years ago, but right now we're not involved in this market at the moment. So this gives a very short overview of our, let's say, products. So we're really specialized to provide MetMasts. What is the MetMast for wind measurement? The main focus is that the structure is only designed that some sensors are installed to the structure, and the structure shall be as tiny as possible in order that the wind flow of the undisturbed air is as less as possible disturbed. So this is the main focus for wind measurement mast, and therefore the used structure is a mast or structure which is guided with guy wires. So in the past we've started with tubular masts. Actually, we sell only really low numbers of them, as they are able to reach heights up to 80 meters. But with number 2, you can see the steel guided mast. This is the type of mast we use right now to more than 90 or 95% in any cases. Then also in addition, we supply steel freestanding masts. As you can imagine, this structure is not very tiny anymore. So we are basically sell these guided masts. Also, we sell monitoring equipment. So let's continue to the most relevant issues. These are the guided masts. We supply them for heights up to 140 meters in the past, but right now we have projects where MetMasts up to 180 meters will be installed. And in fact, these 3 projects will be in Finland this year. So, and also even higher MetMasts are already designed. So freestanding MetMasts are used very seldom, only in very special cases. Usually they are used only in wind farms, where they will be there during the whole operation life of the wind farm. So it's not a big part of our business. But we also supply complete monitoring equipment. So we buy, of course, the sensors itself, and we manufacture the switch boxes, etc., so that it's really made for custom purposes. So, and in addition, in the last 2 years, we've developed power supply, which is especially used for remote sites. So, short overview, and I think so. That's the end of my presentation, and I thank you for your attention.
Thank you very much, Dr. Hochpeter. And again, our Finnish participants are still quite quiet so far, so also you will get a question from me. You were mentioning the power container, so what is so special about it, and what is the reason that you developed it?
Yes, the reason is that in the past years we have had sites which were more located in the north. This was especially in Finland, and there is a requirement also to supply energy for sensors which are heated. during the long winter period. And there you need a very reliable power supply, which can also be monitored very well in order that you get really uninterruptible power supply. And we have a very big diesel tank inside, so that refilling is required only each 3 or 4 months. So we have a very long operational time for this. That was the reason we have developed it, and we have supplied at the moment approximately 10 of these units.
Okay, thank you very much. And let's move on right to the next one. The last one in this block of the company presentations, the company DI David International Hische GmbH, represented by Thorsten Wessels.
Yes, hello, good morning.
Yes, we can hear you and see you.
Wonderful, wonderful. Very good morning from David International Hische GmbH in Germany. My name is Mr. Thorsten Wessels. I'm since 9 years with David International, and I have the post of sales manager. David International is a well-known partner of the shipbuilding and offshore industry and many shipping lines. In this sentence, we have 2 important informations. One is shipbuilding / offshore industry. David International is active in both areas, shipbuilding as well as offshore, so we know the marine market very well. The second is the word partner. We are not looking for just being a supplier, one of your suppliers, ABC, but we want to be a long-lasting partnership with our customers. This is what we are striving for. Company profile. We are a German family-owned company. Founder and owner is Mr. Hische. That's why his name appears also in the company name. We are developing and manufacturing diving systems and cranes with a staff of 175 persons. Those 175 persons are located in the factory you see in the middle picture on the right side. Here we have presently 9 production halls, and each hall holds some specialists, some special department. Like in one hall we have our own electrical department. In the other hall we have the own hydraulic department. The winch building department is there. We have our own shot blasting and coating department. We have our own engineering department located over there. So we have all departments at our fingertips, actually. We are located in the city of Sulingen, which is in the northwest of Germany, about 2 hours driving from Hamburg. Founded in 1978, which means right now 42 years active in the market. So we know the market, we know the business. You will not be only supported by us from Sulingen, but also via a global network of agencies and service stations. The engineering department, we are very proud to have our own in-house engineering department here available. It holds 15 design engineers who are exclusively doing the design work for cranes and davits for us. They are very much experienced since many years in our company, so they know the market, they know the rules, whether it's shipbuilding or whether it's offshore, in and out. Production, we have presently 9 production halls. Number 10 is under erection. It will go in operation by July this year. From the further points mentioned below, I would like to emphasize that we are ISO certified, of course, 9001. We are holding several other certificates also, like 14001, like 18001, And we have a lot of construction workers holding several welding certificates for various materials, be it stainless steel, be it aluminium, normal steel, high tensile steel, and so on. Yeah, we have a flexible production, it is mentioned over there. This is due to the fact that we have all critical departments here in our factory available. And the last point on this slide is customer-tailored production. This is a point which is characteristic or distinguishes DAVD International very much, because we have virtually no mass production. We have a few standard products of DAVD systems and cranes, yes, but the vast majority of our DAVD systems and cranes are produced exactly according to customers' requirement or to the deck situation, prevailing deck situation. We have also test facilities available, of course. Each and every piece of equipment which leaves our factory has to be or will be tested thoroughly. For that reason, we have a winch tower test, for example. We have test platforms for DAVD systems which can be moved into 20 and 10 degrees list and trim condition or situation which simulates a damaged ship, for example. We have several test facilities for cranes, for offshore cranes, be it small, medium-sized, or large. Logistics, our responsibility, of course, will not end at our factory gate. We are capable and able to deliver your product, whether it's small, big, or very big, right to your construction site. The next slide, after sales. Yes, we do have on top of the global network, which you have seen before, we have our own in-house after sales department, about 25 persons. 6 of them are sales engineers deployed worldwide for commissioning, harbor acceptance test, sea acceptance test. They are all certified for offshore missions, so you don't have to worry that we cannot enter any platform. Spare parts, you can rest assured that you will get during the lifetime of your product, which is in any case definitely 20 years plus or 25 years plus. You will get support and spare parts from us. Where can you find our products? In the wind offshore business, on installation vessel, on service vessels for platforms, where we supply live raft davits and live boat davits and deck cranes. On the transformer platform itself, we are represented with small and medium-sized deck cranes and life-saving equipment. And on the wind turbine itself, you will also find very often small cranes for lifting tools and spare parts up to the foundation or transition piece. Yeah, thank you very much for your attention. We are looking very much forward to get in contact with you and being your partner in the offshore business.
Thank you very much, Mr. Wessels. And again, so far no question. We experienced it sometimes later. There's a question, but if there might be a question later in the chat, you can still answer it. But in the meanwhile, let me ask you a question that is always of concern here in Finland. Will your equipment be able to withstand the low winter temperatures, or do you have any experience in Arctic conditions?
Yeah, that's a very good question. Since we have decided to take place in this conference here, I have read a lot of information about Finland. One information, very interesting information, was that the lowest ever recorded temperature in Finland was in winter 1999, minus 51.5 degrees Celsius. I can tell you we can manage with that. Our systems are able to work under such conditions. We have so far sold systems who can operate under minus 52 degrees, so that shouldn't be a problem for us.
Okay, that sounds perfect for Finland. Thank you very much for answering the question. And yes, so that was actually the first part of our webinar, the first part of our German company presentations as well. And we will have a short break now, and then we will be back in 5 minutes with our first Finnish presentation and yeah, the rest of the program. So take your time in this 5 minutes to do whatever you have to do, and then we will see you back in 5 minutes. All right, so short break is over. I hope you got everything you need for the rest of the webinar. And let's just continue right away with our first Finnish presentation. And Heidi is already ready to go here. But just some introduction words to Heidi. Heidi Palati has a Master of Economics in Corporate Environmental Management and is currently the Director of Operations at the Finnish Wind Power Association. She has been with the association now soon 8 years, with a wide range of responsibilities within public relations, advocacy, and communications. And the Finnish Wind Power Association is the leading industry association for wind power in Finland. And Heidi will be telling us some more today about the wind power here in Finland. So stage is yours, Heidi.
Thank you and welcome. Welcome for my part as well, and thank you for the invitation to talk here in your webinar. So, the Finnish Wind Power Association has been established well before the industrial scale wind power construction actually started in Finland. And yes, we are the leading industry association for wind power in Finland. We are 4 in our team. Actually, we could have a poll right after here. So if you go to the polls on the right side in the panel, I hope you can see it.
Yes, we see it.
Might take a little bit for the audience, like 15 seconds or so, but now.
Okay, now we can see some answers there. It seems that many see the Finnish wind market very attractive at the moment, and that's what we consider as well at the moment. It seems that many international investors and actors are very interested in the Finnish wind power market at the moment. But let's move on to see why it might be like that. So to actually wrap up my presentation right in the beginning, before going into details, Finnish wind power market is very vivid at the moment. All new investments are basically market-based with no subsidies. We have a well-functioning permitting process. It's see-through, and it seems that our wind power capacity will double within coming years. We have good wind conditions and plenty of room for new projects. Of course, we have some challenges as well as any markets. One of the biggest challenges that we have is with military radars, and that needs to be overcome to enable the growth of the market in large scale. But now let's see some of these points in detail. So we have some 750 turbines at the moment and somewhat over 2,000 megawatts in production. And we cover some 7% of the electricity consumed in Finland with wind power at the moment. Finland is importing a lot of electricity, so a bit more covered of the production. We import a bit more than 20% of our electricity from neighboring countries on annual basis. And around 22-23, it seems that we will cover about 17% of the consumed electricity with wind power. Industrial scale wind power construction started rather late in Finland, so early last decade after some very slow start. But now we've been on a good growth track for past 10 years. 2018 was a flat growth year, but now good speed again with growth numbers. As said, there's a lot of good room for wind power in Finland. if we compare Germany and Finland, the countries are more or less the same size in area. But there's big difference when you look at the population, as there's only 5.5 million Finns compared to over 80 million Germans. And big difference also in number of turbines. So we have only that 750 turbines at the moment. This is a couple of years old figures though, but the scale is more or less the same still. And closer to 30,000 turbines in Germany. So yes, indeed, we have a lot of room here. So where our turbines are in this large and tall country, most of the turbines are located on the western parts of the country, in northern Finland.
Sorry to interrupt. Herr Bill, Mr. Bill, please turn your camera and your microphone.
Thank you. And in southern parts of Lapland. Now that we have high towers, the construction is moving to inland and east. As we can see here, here's a wind atlas, a very, very rough one for Finland, but there's a excellent wind condition all over the country, and with very high towers we can move to inland, as said. To tell you more about, or the proof about the good wind condition that we have, is the capacity factor of Finnish wind turbines. That was 33% last year. It has been steadily growing every year. And the red line there is marking more or less the 35% capacity factor. And we have a good number of wind farms that are above 35% capacity factor. And as our fleet is rather new, we started construction a bit later than many other countries. So we have modern technology in our turbine fleet. As said, turbines need to be rather high, and Finnish developers have been quite brave to be pilots in testing new types of turbines, very high turbines as well. So good share of Finnish wind turbines are rather large in size. High towers, 157 meters, 160 meters. And the highest tower that we have is 175 meters with 250 meters tip height in Viinamäki site in E. And that's a cable-supported Vestas tower. And talking about Vestas, that's a market leader. Providing turbines in Finland. Nordex has a good share as well. But almost 100% of our turbines are of European origin. Pretty similar map to the earlier one that I showed you, which had the operating turbines on it. This one has our project pipeline, so turbines that are in planning process. And the map looks pretty similar. So the western parts of the country, the northern parts are well presented, but here we can see that more and more projects are also in the eastern parts. Our project pipeline is very large, almost 20,000 megawatts of projects in the pipeline in different stages. Of course, also a lot of early phase projects, but on the other hand, almost 4,000 megawatts of fully permitted, ready to be invested projects. And at the same time, even though we have a very large pipeline, we also have a lot of greenfield project development being started at all times. And also we have a long shoreline, so loads of offshore projects as well, even though we only have one true offshore wind farm at the moment, which we will actually hear more about later today. We keep a list of projects. So we have actually 3 lists on our website. There's one for pipeline, one for operating turbines, and one Excel sheet for projects that have publicly announced investment decision being made. So please visit our website to learn more about the Finnish pipeline. Yes, actually moving back for a bit, we can see here on the map that the eastern part is really quiet, both for operating turbines and for projects. And this brings us to one of the challenges that we have, which I also mentioned earlier. So the military radars are forming no-go areas for wind power in Finland. So that's especially by the eastern border and southeastern areas of the country, and also the sea areas south and east of Åland. This problem needs to be tackled at some point. Municipalities in the eastern parts of the country are partly a bit annoyed because they can't be part of, or they can't have the municipality taxes or the property taxes paid for wind power. And also for the grid, it would be good to have the security of supply, to have the turbines all around the country. But there's luckily some work being done for the matter at the moment that the problem might get solved. Also, height allowances of fully permitted projects is a bit of a problem at the moment, as well as the long handling times of administrative courts. So these are actually bound together in a way that even though our permitting process is very see-through and well-functioning, a lot of projects end up to administrative courts that are lacking resources, and that's why the handling times are very long in the administrative courts. As the wind power technology develops very fast, it often happens that as the project is fully permitted and out of the administrative courts, the height allowance that the spatial plan limit is too low for the newest technology. Also, environmental issues concerning, for example, wolves, birds of prey, and of course reindeer herding are big issues in Finland, especially with some projects, and the studies need to be completed very carefully. End of life and recycling is a growing topic also in Finland, even though our fleet is a bit younger compared to, for example, German wind turbine fleet. A Finnish company called Konenor has developed a new technology for recycling of wind turbine blades. And the technology is ready to be offered for the industry. It's not in wide use yet, but the technology is very promising. And I want to remind that looking at the triangle on the right, which is the waste handling hierarchy. So recycling is higher in the hierarchy than recovery. And so this is recycling technology instead of recovery technology, which is for cement kiln is, for example, representing. But please visit Konenor's site to learn more about this technology if you are interested in it. But it's the market is not only about challenges. We have also very good support for wind power. The public acceptance is very high, over 80% for wind power. Of course, the local acceptance might be more questioned. There was a question about it in the chat earlier, that do we have NIMBYs in Finland? Of course, you have to be very careful with the local community and the people close to the turbines, as the Finnish countryside is very quiet for the background noise, so it's totally new elements with wind power to that environment. The governmental program for that we have at the moment is very good for wind power, as it is very ambitious in terms of carbon neutrality targets that are set for 2035. Also, the strategy for energy and climate will be revised later this year. So we expect some targets to be set for wind power, or at least good guidelines for future energy trends. Also, infrasound is an issue in Finland. Some public conversation around that issue, and that's also raising local opposition towards wind power. But we just recently got a new study about health effects of wind turbine infrasound. The study was by the ministry, so it's very good quality, and there was actually some laboratory tests made to people who claim that they have health issues due to wind turbine infrasound. So more results coming out about that issue later this year, but the initial results were very good for wind power. We will have municipal elections coming up next year, so it's a bit of a question mark what will happen with the right-wing parties, and how will the traditional parties do in the elections. And of course, the municipal level is very important for wind power, as the municipalities have a monopoly in spatial planning, so they can decide to do spatial plans for wind power or not to do them. We have a vision, and that is that 2030 we would have 30% of electricity consumption covered with wind power, and that would equal approximately to 30 terawatt hours of annual production. This seems pretty doable at the moment. We actually see that this will be a vision that will be met. And we got recently a study made by GASUM about grid and electricity market issues, and it seems, according to the study, that 30 terawatt hours of annual production could actually fit to our grid as it is now and assumed to be by 2030. So good news for that. And assuming the COVID-19 situation will ease by October, we are planning our annual Wind Finland seminar for 7th of October. So you are most welcome to learn about more about the Finnish wind power market there. Thank you for my part, and I'll stay here to answer your questions either in chat or right now.
Thank you very much, Heidi, for the overview over the wind energy sector in Finland. And we actually have a question for you. So let me just read that out to you. Due to increasing wind power, we need more flexibility in our power system. Do you have any estimates for that? Do we have a challenge there?
That's a good question. Flexibility is indeed needed in growing numbers, and we do expect that technology also develops there very fast, as it seems now. We don't have any estimations for that, but the study that I mentioned earlier is estimating some electrification and some flexibility solutions to be found, but not in big scale. So there's definitely room for them, but there's room for more wind power production, even if major breakthroughs in flexibility wouldn't happen within coming years.
All right. Thank you very much for answering the question. And maybe there's some more questions coming up later. And as you said, you will be here, so you could still answer it in the chat or. Yeah, thank you very much. And let's move on to actually the next block of our German company presentations. And we already in between got a glimpse of our next presenter, Stefan Bill, who will be presenting Revitec GmbH. And just for you to remember, after each short pitch, we will have the chance to also ask questions to the presenters. So feel free to write them in the chat. But stage is yours, Mr. Bill.
Oh, good morning, everybody. Thank you for the introduction, Ms. Zenker. And I want to introduce you the company Revitec and its technology. So Revitec produces a product which is able to protect and repair gearboxes and bearings in wind turbines. That means in existing wind turbines. So we are able to use the lubricant as a carrier and repair and protect all parts in a gearbox or in a bearing. So, and the biggest costs right now in wind turbines is the O&M of these gears and bearings, and we are able to coat and protect these parts. I want to start with a short introduction of the company first, and then I explain how it works and what's the technology behind it. So the company was developed and started in 2003. We developed this nano and microparticle-based technology close to Frankfurt here in Germany, and we applied the patents in Europe and China and United States already. We have a worldwide office network, so we have production plants in different parts of the world, as well as salespeople on site. And we don't only sell this technology, we apply it on site, and we prove the success as well via condition monitoring, endoscopies, or surface analysis. And we are, since 2019, part of the Croda chemistry group. The target markets are, number one is wind energy, but we work as well in general industry, in the shipping market and in the automotive market. But my focus is right now the wind energy market. So we work in this market since 2008. We have treated at least around 3,000 turbines, all sizes, and we have different kind of products. So we have a grease, which is able to repair and protect main bearings and pitch bearings. We have 3 different types. We can replace the original grease by a coating grease, but we can top treat existing greases in main bearings or pitch bearings as well. Then we have a product which is able to use the gear oil as a carrier, so we can coat and protect gearboxes on site, and the product is calculated, it's 1 liter per 100 liter of gearbox oil. So if you want to treat the general wind turbine gearbox, we need 4 of these bottles to do the treatment and to repair and protect all gear parts internally of a gearbox. So which parts we normally use and apply in? The main application are the main gearboxes, where we use this treatment for the gears inside. It's 1 liter per 100 liter of gearbox oil, and all the other parts are treated with our special greases, coating greases, which are produced by the original grease, which the customer is using already in the wind turbine. So that's the number of wind turbines we have treated, more than 3,000 applications around the world. The track record is in North America, it's a GE 1.5, but we have treated at least all the types you find in the market right now. So the technology uses the grease or the oil as a carrier, and all parts which have high friction, high load, there takes place a physical chemical reaction process, and we can smoothening the surface and fill up the surface valleys. That means we can distribute the load much better afterwards, and it will give the gearboxes and bearing a much longer lifetime. So I show you only a few scientific tests we have done. So we are funded by the German government since 2013 and did a lot of tests related to wear and friction. and we tested the product nearly in all the oils which are used in wind turbines. Then you see when we apply the product, the friction went down by 30 to 50%. That means as well that the turbine will have a higher efficiency afterwards. So we tested in the Castrol, in mobile oils, as well many other oils which are used in the wind turbine market. Then we are able as well to protect the blade bearings, where you find sometimes standstill marks. And we did a test here at the University in Mannheim and only show you a comparison of original grease and the Revitec treated grease. So that's the outlook or the surface of a bearing without the technology. So if you have micro vibration on the surface, you get wear and surface corrosion. And if you top treat this grease with the Revitec technology, you see on the next slide how the surface look like. And in this test, we received about 76% lower wear. That means we can optimize and top treat all gear oils and greases and repair and protect all mechanical parts in the wind turbine which are lubricated by a grease or by oil. A few examples from the field. So we sent our technician in the field, do this analysis on site together with the customer, and you see how a surface looked like before the application on the left-hand side, in the middle after 2 years of an application, and on the right-hand side 2 years after an application. So in principle, we can repair and protect metal surface by using a silicon technology which fill the voids and the surface valleys and distribute the load smart better. That means we get a higher oil film thickness afterwards. Then you see application in a Chinese wind turbine. On top, before you see an area which you have wear, micro pitting and corrosion, and afterwards a nice and smooth surface after a few months. So it's really a repair effect of existing damages in wind turbines. And that means, for example, that you can come from the 10 years lifetime very easy to a normal 20 years lifetime without replacing any major parts. That's a nice picture in a main bearing. So you see the surface before the treatment on the left-hand side, in the middle after 5 months, and the right-hand side after 12 months. So you see the pure repair effect on the surface. And under the microscope, you see the right wear trace, again, before, after 5 months, and after 12 months. So you have about 60% lower surface roughness after the treatment. And that means this turbine will last definitely much longer. That's a real picture of a Siemens 2.3 wind turbine, where you see the surface of a roller bearing before and after, and you see these wear bands, these wear marks are disappeared nearly completely after the treatment, and it's only due to the use of a specialized grease which is able to repair the metal surface. And I think you're familiar with these pictures. So it's a vibration monitoring of a wind turbine. And you see this wind turbine was in a critical phase. They have to stop and reduce the load. And after the application, the vibration went down. The turbine could run in a normal load again. And these planetary bearings you see before and after were smoothened and repaired. And that means as well, the revenues you can generate with a wind turbine can be more generated and more flexible here. So if you are facing any problem, we could help here to repair and protect these special critical parts. So my
really
last slide.
To stop you soon. So
yes, the conclusion is if you reduce the surface roughness in a gearbox or bearing, that means that you reduce the friction and temperature. You have less stress for the gearboxes and the bearings, of course, less stress for the lubricant, and you can repair and protect these parts. And at the end of the day, it means high efficiency, high reliability, availability, and a possible lifetime improvement from 2 to 3 times longer, and a lot of cost savings. I think that's all. Thank you for attention, and I'm happy to answer your questions. Thanks.
Thank you very much, Mr. Bill. And actually, there's one question in the audience, and it is, how can the products be purchased, and are there some special requirements needed regarding usage?
I think they can be purchased in Scandinavia. They can be purchased here at our factory. So we supply to all parts of the world. So it's not a dangerous good. So it's flexible. You can send me an email, no problem at all. And in principle, we need the data of the turbine, the amount of grease, the type of grease, or the type of the lubricant, amount of lubricant in the gearbox. Then we calculate the product and prepare a proposal here.
Okay, thank you very much. And yeah, if there's still questions, he will be still around to answer them in the chat.
Sure.
But let's go on to our next German company, GreenGate AG, represented by Thomas Zapp.
Just 1 second. Oh, yes. So, good morning, ladies and gentlemen. My name is Thomas Zapp, and I will show you now this software solution for O&M management from my company GreenGate here in Germany. I've been working for the company for almost 10 years, and in 2013 I was responsible for the implementation and introduction of the O&M software at the wind farm Meerwind with 288 megawatt in the North Sea. And since 2014 the wind farm is in operation. Click here. That's the next slide. Yes. First, I would like to tell you a few words about our company, then I will deal with the topic of the wind farm management. Another important topic is the administration of certificates, employee qualifications, and the permit management. And finally, I will show you our offshore and onshore disposition tools. Our company is based in Windeck near Cologne with a branch office in Switzerland. The company was founded in the year 2000 and has actually 35 employees and more than 30 other employees in partner companies and distributors. The software is completely produced in our own development department. We currently have over 300 customers with a total of 4,500 licenses. We do offer analysis, consulting, implementation, training, support. And most of our customers are energy suppliers. That means electricity, water, wastewater, gas. But more and more industrial companies are also opting for a software solution so that we have numbers of customers in automotive, food, chemicals, and other industries. In terms of content, our software offers strategic maintenance management, technical management, and the workforce management. Technical management consists of object management. That means you have a direct access to your business object, to the task, to resources like persons, operating resources, and transportation vehicles. The resource planning means you have an effective use of human and operational resources. Document management means you have a simple and clear availability of all documents you need, even in the field. The warehouse management means we have a full integrated spare part management. Then you can do many reports and analysis about every valuation you needed by the collected data. And the last two bullets are mobile devices and interfaces. You do have every information anytime and anywhere. Now I want to report about the wind farm management. First, an overview of the current offshore projects we are dealing with. All these wind farms are managed with our software GS service in the area of maintenance services. In total, there are almost 2 gigawatts, 410 wind turbines, and 7 substations. We choose the RDSPP reference designation system for power plants as a basis for this structure. Here you can find every component and mirroring point of the wind turbines with all necessary property data. Maintenance plans are configured, which are displayed for specific due dates in the task overview. every task has its own checklist to work orders that contains instructions and necessary information about the object data and documents like sketches, photos, manuals. There are templates for working orders that will be generated on demand. The task can be planned, inspections, maintenance services, unexpected troubleshooting tasks. Especially the unexpected tasks are necessary repair works orders resulting from the messages of the condition monitoring system. In earlier projects, documentation was paper-based, as you saw on the last slide. Today, every process is digitalized. The site manager decides which tasks are to be performed in the daily operation and can then synchronize them to mobile devices, maybe tablets, notebooks, cell phones with Android, iOS, or Windows systems. The technician has the information directly available and can start working in the field, including the digital information. The third issue is the management of the certificates to ensure the security. There are a wide variety of safety instructions required. In addition, the software reminds to see the deadlines. So I must go on fasten. The deployment tool you can see here. The complete wind park, there are 100 of tasks to be done, and the software calculates an individual priority using the defined parameters such as the task category, due dates, or critical material availability. So yeah, you have an overview about the wind farm and maybe possible restrictions there are there. Maybe a boat landing is disabled or cranes. So you can fit up the tasks in the timetable to do every work order at this daily plan. So that this is an offshore project, the captain does know where to go with the team to settle down to do the working orders. So this is a people tracking module where you can see the actual position of the ships, of the employees. Maybe in case of an emergency, you can use this by drag and drop, putting the employees, the technicians on the wind turbines, seeing what they're doing there with their working orders. At last, this is an overview about our onshore project. This is a client who has 20,000 wind turbines in Germany, Austria, and France, and he does the daily operation with our deployment tool. So he chooses employees, and then there's an algorithm inside who checks about qualifications and making scheduling here for the daily or work plan. So in summary, GS Service enables operators and service providers to manage their assets, tool, and employees, to optimize the warehouse management, to have the management of the security certificates, and to have a clear and simple team deployment. And last but not least, they would generate evaluations and reports. So what is our aim here? GreenYet is looking for operators, service providers, and suppliers who would like to use the software application for their technical management and documentation. So that was my presentation. Thank you for your attention.
Thank you very much, Mr. Zapp. And as there is no question in the chat yet, let me ask you a question as well. So okay. Apart from wind farm operators, how is the software interesting for operators of other types of power plants, like solar parks, or also for gas or coal power plants?
Okay. Let me say every power plant, no matter if it's coal, gas, wastewater, hydroelectric power plants, has its components who have to be organized. In principle, the software does not care about what type of operation it is. Wind turbines and solar fields are also a type of power plants with similar software requirements. Many coal and gas power plants, hydroelectric and other branches use the software to do their maintenance of. So at the end, I think it's all about saving costs. So we are noticing that renewable energies in particular are dealing with the issue much earlier and are already given high priority to maintenance and software at this planning stage.
Okay, thank you very much. And yes, let's go on with the next presentation. We will have a short switch in the next two presenters. So we will switch for FGH GmbH now, and Energy Meteo will be afterwards because of technical reasons. It's easier like that right now. So next presentation will be FGH GmbH, represented by Melanie Borucki.
Okay, can you hear me? Ah, perfect.
Yes.
Is that already my screen or is that your screen?
We can see your presentation, or we just saw it at least.
Sorry, that was my fault. You wanted to show the presentation. So now you can try to share
So
your
I go
screen.
to files, right? Add new file. No. Shitty.
So just for the audience, Ms. Borucki wants to share her screen. So,
well, you know what? I only go with the slides that we have and have a look at the other screen. Okay, let's do so. Hello, first of all, my name is Melanie and I represent FGH today. As said, thank you for the introduction. We are a technology and knowledge transfer company accompanying the development of the national grids almost for a decade now. And wait, now we have to switch a bit because I have my little. There you go. What's the core behind? No, wait, next. No, I have to switch. Sorry, between the screens. There we go. So what's the core behind the FGH? We are basically a group of 3 companies that combines knowledge associated with different aspects of power system networks, and requirements to knowledge is gained by working with different projects, research and commercial, which is then further continued to the industry through conferences, seminars, and so on. And it's also shared through the present and international working groups for technical standards. No, again, next slide. Here we go. Sorry. No, we take this one and then I go back. So as said, we started almost 100 years ago as a non-profit association, mainly for power system planning of high voltage systems. But as the market and technologies evolved, we also extend our company competences along, so that we are now working also with PGUs and integrating and the affection of the grid. And apart from that, we have a testing, inspection, and certification association, which are, so those commercial daughters are both 100% daughters of the FGH nonprofit association. So now I go one slide back and then two again. So what you can see here is that we have aligned us according to 3 fields of competences, which are electrical networks, power engineering systems, and as said, the certification part. In terms of electrical network, we work with power operators for an optimized planning and development of power networks. In the second part, we work with power plant developers and manufacturers with regards to the integration of power generating facilities. And in the TIC part, we of course offer our accredited services for certification and testing. So there you go. This looks like a lot, and it truly is. But let's focus on. So what we do now is a slight overview of the service portfolio according to the target customers. So here we have the system operators, and in the planning phase, for example, it's important to have a look at the liability and weakness analysis, the power systems and the power system stabilities, which is done by our network group. In the second phase, we focus on the proof of conformity from the point of view of the system operator then again. So do I have everything available for my PGUs to be that it can be connected? And then in the third phase, we have the power quality measurement for grid protection and support of development of technical requirements for system operators and compliance monitoring through fault recorders. So of course, and then the asset management. So the next, how can I, there, sorry, those. in the service portfolio for OEMs, we start with an early planning phase. So we offer our services for entering the new markets through grid code analysis, and then we do a preliminary conformity check for product-based, and on the basis of those analyses, we furthermore go through to a strong networking that we can have technical clarifications. And also we do, this is the next phase then, modeling of our own generation units and preparing the manufacturer's declaration. And we're the leading company with regards to development of FRT testing systems. So finally, which is going to be a quick one, is that what we do for plant operators and system operators. They can focus on technical due diligence and the planning of primary and secondary technologies. So, okay, now what you can see, I actually do have a slide where you see that we've already been working with Finland, and we've did some grid connection studies for various wind parks of 150 MV, which I can't show. Well, I could turn around my camera though. Then you could see. Wait, there you see. And then you see my room and me as well. So that's the improvisation of how life goes when it's digital. So thank you very much for your attention.
Okay, thank you very much, Melanie. And there is no question yet from the chat. But just let me ask you then, what are your hopes?
The camera wasn't on all the time. Oh
no, we couldn't see you.
Oh, good. Then you couldn't see me talking so fast and gesturing with my hands. Oh no. Hello, everybody.
Oh,
sorry. I swear.
We can see you now for the question.
Oh, good.
Actually, there just came a question in, so I don't have to give you mine. I'd rather give you the one from the audience. So the question is regarding your service portfolio. What is your competitive advantage in Finland, and also what kind of partners are you looking for this week?
Okay, as said, actually, what kind of partners? So it's a grid operator. As said, it's according to the target group that we have. So it would be manufacturers and also EPCs and oh, now I'm lacking the words. There's been so many. What's the advantage? Well, you have really a wonderful engineers team, which combines research and development with practical experience. And for example, what we're doing at the moment is a international but mostly European grid code analysis, so that we can compare all the grid codes and know how to connect PGUs to the grids anywhere in Europe and actually over the world. So this is what we're doing.
Okay, thank you very much for your presentation and for answering the question. And let's have the last presentation now from the German company presentations. And this will be now Energy and Meteor, represented by Eike Arndt.
Hello all together. I hope everyone can hear me well. So today, welcome from Germany, and I would like to present the company Energy and Meteor Systems and our services for the wind industry, especially in Finland. The first short summary about the company: we were founded in 2004 by the two owners. They did their PhD about wind power forecasting, and then they decided to found a company to sell this product. And we were growing and growing, and now we are about 100 employees, all based here in Oldenburg, north of Germany. And our company is mainly divided in two departments. One is the forecasting department, and the other department is about the virtual power plant services. Main services in forecasting are wind and solar power forecasting for single sites or regions, and the virtual power plant is used to combine decentralized energy production or consumption units into one big software solution to act with it as if it is one big power plant. So then we have some specialized products I want to introduce today, like the vertical grid load forecast, which is a product especially for grid operators, for TSOs or DSOs, to forecast the load between different layers of the grid. And I would like to introduce some services around SOGL and redispatch, which are perhaps especially interesting for the plant operators also in Finland. We are doing also a lot of consultancy and research and development projects with international agencies in different countries. Who are our clients? Our clients are mainly the grid operators or the trading companies that are responsible for the physical trading of the energy that comes from decentralized wind and solar power plants. And also in some countries, there are a lot of plant operators that require forecasts for purpose like doing technical operations or having the obligation to provide forecasts to the grid operator. At the moment, we are already active worldwide, providing forecasts in most of the developed countries worldwide, doing the forecast, for instance, for about 85% of the United States in regarding to the wind. So most of the independent system operators in the United States, for instance, are our clients, but also a lot of TSOs in Europe are our clients. So we work for the grid integration a lot of wind power. At the same time, most of the big utilities are our clients. So they have to integrate the renewables in markets. So that's the other purpose for the forecasting. So what is, when I'm talking about forecasting, we already heard about forecasting today, but that was like site assessment, and we're doing the operational forecasting. Operational forecasting means from now up to 10 days in advance, and with a resolution down to 5 minutes, and we can also do an updating of forecasts every 5 minutes. This is an application for the United States, for instance. We collect the real-time measurements either through the virtual power plant solution or from our clients, and then we update the forecast we can update the forecast very frequently. And then we support all types of transfer mechanisms, and we have our own 24/7 service desk. So three people at the same time are working for our clients, because they are spread all over the world. So we'll have to have 24/7 people working in our office. So short introduction to vertical grid load forecasting, which is a special product for grid operators. There we not only forecast the wind power and the solar power that is generated, we also can forecast the vertical grid load, which then, so perhaps a short introduction of the graph. In gray, you see the vertical grid load that was the result of load and production. And if you subtract all the forecasts from solar and wind, you get a typical load shape in red, which is then better predictable load forecast also for the grid operator. Only a short, quick overview of the virtual power plant solution. The virtual power plant solution is the other department in our company. There we have developed our own software solution. the virtual power plant, which is used by a lot of different trading companies around the world to integrate the renewables into different types of markets. At the moment, the virtual power plant solution is used by about 100 traders and is actually connected to about 80 gigawatts of installed capacity worldwide. Most of it in Europe. There we have about 50 gigawatts of connected renewable capacity, and most of it is remote controllable for the trading desk through the VPP solution down to the assets. So thank you for your attention.
Okay, thank you very much, Mr. Arndt, for your presentation. And one more question from my side. How are you handling icing of wind turbines in your forecasts?
So yeah, icing is a topic for the Nordics especially, of course.
Yeah.
So yeah, we do the power forecast, for instance, for ISO, the Canadian ISO. There we'll have to have a lot of icing, as well as for some ISOs in the United States. So if the blades don't have heating, then we'll have to calculate in which conditions there could happen icing. And we do this using a lot of different parameters from the weather models. And then we take this into account, can calculate very, very good, in average, a very good forecasting of when it happens and how long it will last. So it's very important for the traders and also for the ISOs to know when it will disappear. So it's not, it's very difficult to forecast, and we're doing that already for years now in different cold countries.
Yeah, that sounds good. Thank you very much. And we are staying on the subject of icy conditions with our last, but not least, of course, presentation. So please hold on for one more very interesting presentation of our second Finnish speaker, Jarkko Kleemola, who will talk about offshore wind farm in icy conditions. Jarkko has a Doctor of Science and is the Director of Technology at Suomen Hyötytuuli Oy. And since 2009, he has been working in the wind energy sector in many different roles, starting from group manager of wind turbine gearbox manufacturer to his current role now as Technology Director. And his current responsibilities include the improvement of production capabilities and tools, for example, by offering better production energy forecasts or developing predictive maintenance algorithms for monitoring. And for our German listeners who are probably not so familiar with Suomen Hyötytuuli, Suomen Hyötytuuli built Finland's first offshore wind turbine outside Takkaluoto in Pori in 2010, and Jarkko will now tell us more about that.
Yeah, thank you, Christina, for introduction.
Sorry, when I can step in, Jarkko, maybe you can try to share your screen. I can't see your presentation here in the system right now. I'm sorry.
Okay, so it's I should have a presentation there, but
sorry, it's probably my fault. But I'm still checking. But maybe you can try in the meantime to.
Then I will try to do that.
Yeah, so it worked quite well before.
Yep.
With another attendee. Thanks. Sorry for the inconvenience.
Okay, can you see the presentation?
Yes, everything perfect.
Okay, good, good. So I will tell you about the Tahkoluoto site, which is it's a offshore site in icy conditions in Finland. But I think we can actually start it from the pole. Can I start it that one, or can you do it?
I don't have any control now.
Okay, so I will start the poll. So the question is, if you
sorry, I was not. Yeah, the poll. Yeah, one moment, please.
So the question is, do you know if the cold of Botnia is freezing in every year? And there is a simple answer: yes or no. And let's just wait a little bit. Yeah, we are getting answers. 60% yes, 40% no. Okay, I think it's coming more and more 50-50. Okay, I think I will end it up now here. So it's more or less 50-50. It is actually so that it's not freezing every year. It depends what part of the sea we are talking about, but we will go that in a later on, and you can see a little bit the icy conditions that we have there. So here's some outline of presentation. So I will tell you a little bit where is actually the Stockholm site, what kind of advances and disadvantages we have there, what type of turbine we are using, then the gravity-based steel foundation that we use there, ice load calculations, then really shortly about our project and how that went, the construction phase, production service, and access to turbines. So here is, if you are familiar on Sweden and Finland, then you probably know a little bit where this location is actually. So Helsinki, maybe you know our capital. So you go a little bit north from there and then a little bit from the west. And there is a city called Pori. And this side is front of that. The mean wind speed there is roughly 8 meters in a second. Then there is some other parameters which you can see there. Maybe the temperature is something that is interesting for you. So it is from plus 30 to minus 30 degrees. Here's also these small red points. There are the turbines that we have in that area. It's totally 11. It's also showing where the substation is, so it's an onshore. Where is our service vessels located, pre-assembly area, what we use in commissioning phase, and also where is our service hub. The Kokemäki River is also showing in a map, and it is actually helping us, but we will come back on that in later on. So advances and disadvantages. The Kokemäki River, as I said previously, is actually helping us, and it is keeping the port open from the ice most of the winter. The port of Pori is of course helping us also. It is giving us infrastructure which we need. We have a grid connection close by. This is also a very important point that the local attitude is really positive. So they are used to wind turbines already 20 years, and this offshore side is also causing a really positive attitude actually. The sea bottom properties, it's a bedrock which is really close to the surface, so it's really hard rock. And this is actually causing also that the classic monopiles cannot be used in that area. The wind conditions are one of the best in Finland. The disadvantages in that area is that, of course, it's cold. You have to take care of that. You have ice loads, and sometimes you have a frozen sea which limits your access to site. The turbine which we used there was the Siemens 4.2 megawatt. It's a really reliable turbine. It's used worldwide, and that was the criteria why we selected the turbine in this project. And environmental conditions didn't require that we actually have heating systems for the blades in that location. It is actually so that we really rarely see that the blades are actually icing in that area. The gravity-based steel foundation is shown here. So it's this kind of open bottle, which you are then putting in the bottom of the sea, and then you're filling that with the gravel or something, some material. And it's actually our own design. And then now we are going the ice loads conditions and also the icing generally. So in this area where we have a pilot turbine from 2010, we have actually seen 2 really hard winter times. So otherwise it has been almost open sea. But nevertheless, you have to take care of the icing loads in the design phase, because it might happen that we have really severe ice loads there. And we don't have any protecting archipelago in front of the turbines. It's an open sea until the Swedish coastline. We use 3 different kind of ice loads in a calculation phase. Yeah, from the project and schedule phase, the project was happening in 2016 and 17. We were taking care of the management ourselves. And then turbines installation was coming from the Siemens, foundation from the Technip, cable from Prysmia. Then Jan de Nul was coordinating all marine operations. And under that, there was different companies who was doing some subtasks for them. Then electrical network interface was coming from Pori Energia, which is actually one of our owners. And ABB was delivering us onshore substation. Yeah, winter also limits us in construction phase. So mainly we did all the sea operations between the April and October at these years 16 and 17. And here you can see in the left picture is actually the area where we make the pre-assembly. We use the jack-up for crane also for pre-assembly tasks. And in the right picture, you can see where they are placing the foundations at the sea bottom. Then production and service, and now we actually have been operating 3 years this side. We are doing the service ourselves with the support of Pori Energia. The crew transport vessels and the other vessels that we need for let's say for smaller maintenance tasks are coming from the Finnish Sea Service. It's a local provider, and vessels needs to be suitable for operating frozen ice. The downside what we have and the biggest risk in this project is that there is no jackup available close by, because we are the only offshore site in the Gulf of Bothnia. Then for Port of Pori there is one icebreaker which is supporting our operations, and that is the in the lower part middle picture, this Pori Karhu is the name of that vessel. Access to turbines. So the biggest thing what is actually there is the waves and winds, which limits our access to turbines. The other problem is that even if there is an open sea next to the turbines, but we might have difficulties to get out from the port because the port might be frozen. And that's why we also need sometimes icebreakers, that we can release our crew vessels and then we can manage to go out. The other thing is there that usually if the sea is open or still open, the boarding land is actually quite icy and it's difficult to climb up. And this was why we make this kind of boarding lamp heating system to support to able to go there more safely. And this is working so that we can turn it on remotely from our hub. And so when we know that we are going there, we turn it on maybe 6-7 hours before. And then there is coming a small water layer between the ice and the steel structure. And when you are coming then to the area, you are maybe pushing a little bit with the crew vessel, and the ice is more or less collapsing down. So this layer is helping for getting rid of that ice. So it's not totally melting all the ice, but it's just making this small layer, and then it is easier to hammer that ice out. Yeah, and I think we had actually 2 polls more. One is, let's see, where was that? Yeah. So how many megawatt of offshore wind power are installed in Finland? Is it so how many it is now installed at the moment?
There are still questions coming in. The audience can't see that, what we can see here, but as soon as we don't see any blue diagrams moving anymore, then we would publish the result. But there's already a tendency.
Jakob, we can't hear you anymore.
Sorry. So now you probably can hear me. Okay. So the right answer is 44 megawatts. So our side is the only side at the moment, and there is also in the north some semi-offshore side which is actually built up in the islands, and in the commissioning phase they have used mobile cranes, but we are thinking that we are the only real offshore site at the moment. I think we also have one other questionnaire. Yeah. So what is assumed potential of offshore wind power in Finland? This is something that is actually, I was picking up this from Baltic Offshore project, and it's some kind of estimation how much we believe that it's really realistic to have in Finland in the near future.
Now we have the result.
Yeah, okay. So we believe it's our area of 3,000 megawatt. It depends now how the development is going forward. Of course, the size of the turbines are increasing all the time, and this is maybe also increasing the possibilities. But let's see. But currently, what we estimate that it's really realistic to have a 3,000 megawatt in offshore. Good, and I think that was the end of my presentation. So thank you for everybody.
Okay, thank you very much, Jaakko, for your presentation and the polls, which were very interesting. And actually, we only had one question, but I think it already got answered now with your last poll. And also, Heidi already said something, so I guess we can give it a wrap here. Thank you once more for presenting at our webinar, and we will still see you later for some meetings as well.
Yeah, thanks.
Okay, but we're through basically, so with just a little delay, I think that's okay. To wrap it up, just let us show you how this conference actually could have looked like if COVID-19 wouldn't have banned us all to our living rooms today. So shortly we will show you a short video of our conference that we had last year in person. But first of all, of course, thank you all very much for attending today and listening to all our presentations. And hopefully we'll see you again some other year when we have another interesting energy topic coming up in the following years, in person or online, who knows. Let's see how this develops. And until then, all I have left to say is stay safe, stay healthy, and hopefully see you soon sometime. So enjoy the video and have a good day.